We're back. We're doing this straight off the rip. Hopefully this video isn't too long. We're doing GLM part 2. This may be part 3 actually. Yeah, it's part 2 of looking into the code, but this is the third video with respect to the Groot language model. So we have the plain version of the model in code, and then hopefully because it's plain it'll be easier for me to read. I'm not sure if I have the voice mode guide markdown file for the voice. I plan to do like the same video, but just, how do I say it? But the code's simpler to read. So let's just like really jump straight into it because it's late for me right now and I want to go. I want to go home. Okay, so this just isn't a good format. Let's see. So we have it. What's in here? So this importantly means that there is not a tor. Yeah, there isn't a tor.md for the plain version. That's fine. Let's try, let's see, Control J. Let's see if I can cd glm, how do I say? Where did my phone go? Where's my camera? Okay. Ooh, there we go. What is it? GLM plain. Okay. And then what are we looking for? Python generate.py. And this is just a test if by the end of last video, in theory, I should have a trained model for which I can talk to. Interesting. Generate.py. I wonder what it would be waiting on. Oh, okay. Let's see. Oh, it took that long to load the model. Let's see. So we have, ooh, I wonder if, how do I say, I don't have the answer for when it ends a sentence. Is, let's say, I am, it's just say Groot. Yeah, I am Groot. I am Groot, question mark. Oh no, Groot's message. Interesting. So I said I am, and then it said I am Groot. So let's see, question mark, I am Groot. Let's see, I am Groot. I am Groot. Groot, I am Groot. Let's see. Groot. Groot. Groot question mark. I feel like that should break it. Goot. Goot. I am Groot. I'm curious if these question marks, this is my message being regurgitated with a question mark. I think that might be an edge case thing. I'm not sure. I don't know if the question mark is tokenized, but I'm imagining it's like Goot is not a token. It's not in our vocab space, so we shouldn't be able to construct it. So this must be like a Python thing, like, oh, it was just a Python. Python. Like they should break it. Yeah, Python Groot, that makes no sense. So it's continuing where I left off, including what I sent. So it's not meant to be a conversation, I guess. Nice. Okay, but the model works. Perfect. And importantly, yeah, that's the plain one. So let's get into it. So let me prime my mind by recalling it cold. Config is just going to be a configuration data object that we're going to call in our other files. This is really just a class. It's just an object. It's really just an object in this like dumbed down Python version. So this is perfect. Yes, I love that. That's much better on legibility. It's model architecture, training, tokenizer, and then paths. Perfect. So that's our config. We'll be using it in other files. Fine. DataGen. DataGen should not exist here. DataGen we're not even going to look at. DataGen should exist in data. Uh-oh. There we go. So we don't even have to worry about that. Data loader. Okay. Turn the corpus into training batches. Build token IDs. Let's see, group data set. That's it? This is the whole thing? Whoa, this is so small. Okay, so build token IDs is it takes the config and it takes the tokenizer. Where's the tokenizer? Is the tokenizer something that got built by the, how do I say, by the config? Who's using build token IDs? Tokenizer. Where's the tokenizer object? When does that use? Scroll. Let's say, I don't know, if we run it, then we pull the config sequence length. So we're defining the config, we're changing it. Batch size is going to be 8. Fake equals torch. I think this is just like a list. I don't know. Array range, maybe. DS, data set. Okay. Is group data set fake? What's this? Where are we? Token IDs. Oh, it's a fake set of token IDs. I wonder why we're doing that. Self-test the XY. Oh, I see. This is just testing if we can. Okay, perfect. DS is, yeah, okay. Data set and then config subject to the configuration. Cool. Data set get batch. So this is just a test. You know what I mean? Is torch dot generator? I don't know what that is. Manual seed 0. I don't know what a generator does. Get batch generator. So a generator starts equals rand inits generator. Oh, it's a RNG. It's a random number generator. That's interesting. Random number generator is torch.generator. Okay. Okay, but this gets the batch. I have yet to see the initial question of, okay, so we have this function and we put in the tokenizer. Do we even care? Let's see, config, read the corpus, encode it, and return the 1D tensor of IDs. Let me think about this. Read the corpus, encode it. Build token IDs. Yeah. Data loader. Why? I find that strange. Why are we building the token IDs inside of the data loader? I wonder what calls this function. Is like, so we're gonna tokenizer. That doesn't make any sense. The tokenizer isn't going to be immediately used. I'm group. We are group. Yeah, so this confirms if the tokenizer works. Okay. Model isn't using the tokenizer, right? So if we go to train, then we have the tokenizer and we have the data loader and build token IDs, which for some reason is not being used at the same time. Is overfit one batch, and then also an actual main is get tokenizer. I don't understand that. Why would build token IDs? Let's see. Does it do something like tokenizer.encode? Okay. So the tokenizer file is going to build the tokenizer, and someone has to use the tokenizer, and I guess it's the data loader. Is the tokenizer isn't what builds the token IDs, and the token IDs have to be built somewhere. So I guess, it's a weird middle ground of the tokenizer gets applied at that stage. So let's see. Wait, what does that say? Get tokenizer from config. Interesting. Okay, but this is just supposed to be easy. So this is calm. Get the tokenizer. And this is, let's see, the path exists if blah, 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 blah. Return time. Oh, this is just, how do I say, if I've generated a new data set. So if that's fine, then yeah, whatever. Then we'll relearn it. If not, then we'll, how to say, in both cases, these are a tokenizer. Okay. If, yeah, text. So yeah, so then we're going to train it, and then we're going to actually save it to the path, I guess. Yeah. Tokenizer train.bpe. I wonder where that's coming from. So the tokenizer lets us also, how do I say? Where's the function? Encode, decode, save. Perfect. It'll save it to the path. Okay. Training. Overfit one batch. That's just a test. Support loss curve. Whole bunch of helpers. Compute loss. That's whatever. This is importantly returning the PyTorch function. Cosine learning rate. I find that interesting. Linear warm up, then cosine decay for the learning rate. Interesting. Okay. We get a device. Tokenizer. Oh boy. Hmm. What if this video ended up ending very early? I'm feeling very underwhelmed by this. In the sense of like, okay, I guess I want to build something from scratch at some point. Ooh, let me ask that. Hey Tony, I have a quick question. So we have two examples of important code. There's GLM, there's GLM plain, and then there's implement. They all are sort of quite similar to the Llama 3 model architecture. What I have a question about is if you go into deep DL, is we also have a reproduction of the coconut paper from Meta. I want you to answer for me, you know, what's the relationship between the code for the training run in deep DL or for coconut and these GLM and implement folders and models? Are they quite similar? You know, what transfers, what doesn't?
Let me search the Coconut repository to see how its model architecture is defined. The relationship between the Coconut code and your GLM or implement folders is a classic case of a wrapper versus a core model. In terms of what transfers, the core transformer architecture is highly similar. Coconut is not a new transformer model built from scratch. Instead, it is a wrapper class that takes an existing causal language model, like GPT-2 or Llama 3, and modifies how inputs flow through it. What transfers directly is the underlying transformer block mechanics. The attention math, key value caching, position embeddings, and feed-forward layers in your GLM and implement folders are exactly what Coconut relies on under the hood. What does not transfer and what makes Coconut unique is how it handles the input embeddings. In a
Okay,
standard
but so hold on, pause. Let me think about like the actual code. You're telling me that the wrapper doesn't have the model architecture built from scratch. It just, I don't know, it calls it from where? There's like, are you telling me that there's an existing GPT-2 model object, so there's no need for a model.py? You know what I mean? Hello?
Yes, exactly. In the Coconut code, there is no custom model.py defining attention or feed-forward layers from scratch. Instead, it imports GPT-2 LMA head model from Hugging Face's Transformers library. When the Coconut class is initialized, it takes that pre-existing model object as an argument called base causal. So instead of writing the transformer blocks yourself, Coconut just calls self.baseCausal to do the heavy lifting, while it focuses entirely on intercepting and swapping out the input embeddings with those continuous latent thoughts.
Okay, so the model, yeah, the model already exists. It truly does rely on a wrapper. So so the coconut reproduction isn't very complicated.
You nailed it. The model itself is just a standard Hugging Face import, so the code is actually quite lightweight. The only real complexity in Coconut is the index gymnastics. It has to find where the special latent thought tokens are in the sequence, pause the forward pass, grab the hidden states from the last layer of the previous step, and manually inject those continuous vectors back into the input embeddings for the next step. So while the transformer math is completely outsourced, the engineering trick of hijacking the embedding space is what the wrapper is actually doing.
Okay, so let's pause. Let's think about motivations. Reproducing coconut. There's reproducing coconut from scratch, like on a PyTorch level. There's doing something new. There's just going straight to doing something new. The reproduction, I feel like the reproduction I want to do from scratch. I don't know. I'm curious about the benefit of that. So like, what if I gave myself my own blue? You know, like my own code base of like, you know, like my own like model data, everything, etc., like from scratch. And that's just like scar tissue. That doesn't help me reproduce the paper like too much. But then also being able to reproduce the paper, coding it from scratch, I feel like that's more of a that, you know, that's sort of a bigger test of like my fundamentals. Is like I don't want to test if I can, how do I say? I don't want to test if I can use a wrapper, but maybe I'm, how do I say? No, I don't think I'm shooting too far doing that. These are, how do I say? It'll complicate itself, you know what I mean? So, hmm, hmm, hmm. Okay. I think I need to, I think I already have the answer. Is, okay, I look at the code, I look at all the files, I understand the parts, I'm not impressed by anything. I would code this differently. You know what I mean? This isn't what my code would look like. So, we're there. We have the names of things are gonna is like weird and confusing, but we understand the fundamental is the GLM plane and like the code from class. This is all quite similar. The everything is leaning on a data set, a tokenizer, a model, and a trainer, and a data loader. Yeah. And like how do I say it? You know, like how you load the data, all those things, etc. Those are like choices, and like I want to like yeah, I want to have like a set of experiments of like okay, so I train this, and then like you know I change this, I change this, I change this, I change this. You know, I want to build like all of that like sort of like intuition stuff, and I think that requires the like doing it from scratch. We're still not going to go all the way that far into the. We're not going to go so far that I'm hand typing code. I'm already done reading this. I think the next step, and so maybe this video is short. I think the next step already for what I want to try to do over the weekend is I make my files. You know what I mean? It's like so I get my whiteboard. I know what I think I want to do. Um, we're going to have to do it in PyTorch, and I'm just going to ask a whole bunch of questions like, well, I'm trying to do this in PyTorch. Well, how do I do this in PyTorch? You know what I mean? And like I'll section everything off, and then it'll fail, and like we'll try again. Um, because this is very nice validation. It's like, how do I say? Having this like AI slop code is making it easier for me to think, oh, well, okay, let me just go ahead and try it. You know what I mean? Is it's demystifying, whether or not I could do this from scratch. Um, is like there's just a lot of scope bloat that you can just add to code. So yeah, I was like, I would try to do it from scratch. It's like, okay, so like let me get a data set, let me tokenize it. Okay, so how am I gonna pass this? Blah 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 blah. And like, yeah, it's like I want to have my own library of the things that I'm using. And again, that checks off a lot of boxes of things that I care about. So I think that's a worthwhile. And that'll be exciting because that means that's our answer. Is next video is the first video. I'm going to open a blank .py, and how do I say the way I'm limiting things is I think I'll only have voice, and I'll do so like file.py, and how do I say it's like I'll speak things out loud, and I say like give me a I don't know, a LLM config class. You know what I mean? Is like, okay, I can still vibe code here. Ooh, this is quite interesting. That it's not. Is this Python? Oh, it is Python. This is way too much code at once. You know what I mean? But like, you know what I mean? It's like, okay, this is on a function level, and that means that the agent does not have the big picture, which means the big picture falls onto me. You know what I mean? So that forces me to understand the big picture, not the functions. Perfect. Or like I'll understand the functions because I can question each function, or I can like ask about, oh, how does this function work or whatever. But as long as the way that I scope the agent is that we're not using the side panel agent. It's not generating multiple files. I'm only allowing AI to generate a thingy, and then I can also importantly ask. So how do I say? Give me a recursion example. Is it Fibonacci? Ooh, the factorial. Okay. So we have an example of recursion, and I say like, okay, how does this work? And then in all of the directions of like, how do I say? I can either do it in voice or I can just ask here. You know what I mean? It's like, okay, simple. you know? Exactly. So I can have code, we'll ask questions about it, we're live in it. Ding 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 ding. I like that. And yeah, almost like we could like be silly enough and like try to do it in one file. I think the main thing that I'm missing is like is PyTorch if I want to do backprop. So we'll just go straight to PyTorch. Is I would like to do NumPy. You know what I mean? It's like I would like to do like the forward pass and sort of like work with what I'm familiar with, and then like NumPy is already a little bit more pure in a sense, closer to like I don't know, closer to like nah, I don't deserve that kind of credit, but it's like closer to like an actual whatever, like closer to C in a sense. Um, but yeah, is so okay. So we're gonna bring back the iPad. I'm gonna be whiteboarding stuff and terminal and functional level vibes because now we're um the depth of my architecturing requirements, the gaps in my ability to architect this are going to be completely revealed. In our last run with the vibe code, any gap I had was filled. You know what I mean? Any like data type connection, blah, blah, blah was filled. I can't do that because I don't have an agent that's building across files, So perfect. But I can still ask it like the questions. And it's just up to me to be honest of like, say, like, of like, well, don't cheat and just like say, oh, well, since you have all the context, we'll just build this function, you know? Um, perfect. I think that's where we're gonna start next. Cool. I'll see you next